This lesson is called Solving Right Triangles. We want to be able to use trigonometric ratios to find side lengths and angles of right triangles. Okay, we have been using our trig functions to find side lengths, and now we're going to look at finding the angle measurement given side lengths. The inverse trig ratios. Let angle A be an acute angle. In other words, it's either going to refer to this angle or this angle, but never to the right angle. So the inverse sine, this is how you usually see it written. The inverse sine of, and this is going to be a ratio in here. I'm just going to put it in parentheses, of something. And that's going to be equal to the measure of the angle. So here it's saying the inverse sine, if the sine of A is y, so in other words, that could be 0.5387. So given that you know what that ratio is, you can write it as a decimal, then the inverse sine of that number is going to be equal to the angle. And the same for the inverse cosine and the inverse tangent. The way you write the inverse sine is you put this -1 up raised, like you are raising it to a power. Okay, let's look at some examples. Okay, if we're going to use this picture right here, and we would say the inverse sine, okay, so the inverse sine of BC over something. So here's angle A. Sorry, we're looking at angle A. So the sine is opposite over hypotenuse. So that would be BC over BA is equal to the measure of angle A. Make sense? Let's look at the next one. Okay, we have the inverse cosine, and again we're looking at the measure of angle A. That's better to kind of work from reverse. So cosine is adjacent, so this would be my adjacent side from angle A over the hypotenuse. So it would be AC over BA. Okay, and then tangent. So the inverse tangent, looking at angle A, it is opposite, so this, over adjacent. So it would be BC over CA or AC. All right, let's look at an example to solve. So example 1. The measure of angle A is equal to the inverse sine of. So if we're looking at A, again, they're just wanting us to put the sides now. We don't have any values for the sides yet. So that is opposite, so that's going to be SH over the hypotenuse, which is HA. Okay, the measure of angle A, so again we're still looking at angle A, is equal to the inverse tangent of. So the inverse tangent is opposite over adjacent, so opposite is still SH, or you can write HS, it doesn't matter, over the adjacent side, which is SA. And then still looking at angle A, the inverse cosine. Well, cosine is adjacent, so that would be SA A over hypotenuse HA. All right, so see if you can write them for angle H. So please pause the video and try and write them yourself. Okay, hope you paused. We're looking at angle H. Sine is opposite over hypotenuse, so SA over HA. The tangent is opposite over adjacent, SA over SH, and cosine is adjacent over hypotenuse, so SH over HA. Okay. So now we finally get to where we're actually going to solve and find an angle measure. So the measure of angle D. So we're looking for this angle right here. We're also going to look for F, but let's start with D. So we have all three sides, so really you can use sine, cosine, or tangent. It doesn't matter which one you use, but so I'm going to use sine. So the inverse sine of, so if I'm looking at this angle, sine is opposite, so 21 over hypotenuse. Now I'm just going to put that in my calculator. And so I'm going to, in my calculator, I don't know if y'all can see that, okay? In my calculator, I am going to go to this right here where it says trig. I'm going to press trig, and then you should see the trig functions come up, and you want to go over to the one that says inverse sine. So they're on the bottom there, inverse sine, and just press enter. And then in that parenthesis, enter 21 divided by 29. And you press enter, and it gives you 46.397. You can round these to the nearest degree, so that would be 46 degrees. Hopefully you can see that, okay? If not, you can look it up in the table. You would just put 21 divided by 29 into your calculator, and then look that value up in the table and look for the angle measurement under sine. All right, let's do F. So now I'm looking at this angle. So I could again use sine, the inverse sine, but when I'm looking at F, the opposite side is 20. 29 is still the hypotenuse. So I'm going to go back to my calculator. Inverse sine, 20 divided by 29 is 43.6. So I'm around to 44. All right, please do the quick check. Again, you should pause and try it yourself. Okay, hope you did. I'm looking at angle A. So let's use cosine this time. The inverse cosine. So for cosine, if I'm at A, it's adjacent. So 5 over hypotenuse. So the inverse cosine of 5 divided by 13. 67.38. Round to 67. Now we'll look at B. Use tangent. The inverse tangent. So from B, tangent is opposite over adjacent, so 5 over 12. So you have a lot of choices. You'll get the same answer either way. Inverse tangent, 5 divided by 12 is 22.6, so we'll round to 23. Okay, 2 more examples. Find the missing measurements of the right triangle and round to the nearest tenth. So here, they ask for the measure of angle G. Well, we know that all the angles have to add up to 180, so this one and 55 together have to add up to 90, so that would be 35 degrees. Okay, so now if we want to know the length of GJ, let's see. I'm going to go ahead and I'll use this angle. Looking for GJ, so I'm just going to put an X there. And so this is going to be, I'm going to use the sine of 55 equals the opposite over the hypotenuse. Cross multiply, I get 15 equals X times the sine of 55. Then divide by the sine of 55. Divide by the sine of 55. So X is equal to 15 divided by the sine of 55. 15 divided by the sine of 55 is 18.3. All right, then LJ, just use a different color. LJ is right here. I'll just call that Y. And I think I'll use tangent. The tangent of 55 equals 15 over Y. 15 equals Y times the tangent of 55. So just divide both sides by the tangent of 55. Okay, so we get 15 divided by the tangent of 55. 10.5. Okay. One last example. It's a quick check, so please pause the video and see if you can do it yourself before checking your answer. Angle A, these two have to add up to 90. So let's see. That would make this 58. Okay, and then, so angle A is 58 degrees. AC, I'll call that X. So I think, where's your hypotenuse? This is my hypotenuse, okay? It's across from 90. So I can do the sine of 22 equals the opposite over the hypotenuse. So here it's just going to be X is equal to 8 times the sine of 22. .996. So I'm just going to go ahead and call that 3. 2.996. You can round that to 3. And now let's look at BC. Let's just call that Y. So I may, if I use this angle 58, I can use sine of 58 is equal to Y over 8, opposite over hypotenuse. So I'm going to cross multiply, and Y is going to be equal to 8 times the sine of 58. .78. There you go. All right, hopefully these are starting to make a little more sense. We're going to have one more day of review tomorrow, and then on Monday you're going to have a quiz. All right, so let me know if you have questions.